जी अस्सलाम वालेकुम जी। आज मैं आपको फिर मार्च 2024 पेपर 1 2 कराने लगा हूँ। जैसा कि मैंने चैनल के ऊपर नोटिफिकेशन में डाल दिया था कि आप इसको पहले कर लें। आई होप कि आप लोगों ने कर लिया होगा, और अगर नहीं किया अभी आप ये लाइव स्ट्रीम देख रहे हैं तो जब बाद में रिकॉर्डेड देख रहे होंगे तो उसमें ये है कि आपने जो है पहले हर क्वेश्चन को खुद सोचना है। मेरी यही फिलॉसफी है, मेरा यही मानना है और यही एक्सपीरियंस है कि फिजिक्स जो है वो आपको करने से आती है, सुनने से नहीं आती। जितना आप ज़्यादा क्वेश्चंस को सोचेंगे, जितना आप ज़्यादा क्वेश्चन में अगर आप स्टक हो गए हैं और आप दोबारा सोचना शुरू करते हैं तो उससे आपकी लर्निंग ज़्यादा होती है। अगर आप किसी क्वेश्चन पे फर्स्ट अटेम्प्ट पे आप स्टक हो गए और आप फौरन टीचर के पास ले जाते हो तो उससे प्रॉब्लम हल नहीं होगा, उससे आपकी लर्निंग जो है वो इन्हांस नहीं होती। तो हम इसको स्टार्ट करते हैं। आई होप कि आप लोग भी इस पे सोच रहे होंगे, और यही मेरी ख्वाहिश है कि आप लोग इसको ज़रूर सोचें, साथ खुद करें। वीडियो को स्टॉप करके करें अगर आप बाद में देख रहे हैं, और अगर आप लाइव देख रहे हैं तो फिर भी जो है मुझसे एक स्टेप पहले जो है वो आप लाजमी देखें। ठीक है। तो आपका टाइम ज़ाया करने से पहले जो है वो टाइम ज़ाया करने के बगैर जो है इसको स्टार्ट करते हैं। सो पहले क्वेश्चन पे चलते हैं जी। पहला क्वेश्चन क्या है? मैं जब आपको जस्ट आइडिया दूंगा, एग्जैक्ट कैलकुलेशन शायद ना भी करूं, और मेथड बता दूंगा, बाकी आप लोग कर सकते हैं। ओके जी। विच रो शोज द फिजिकल क्वांटिटी एंड इट्स बेस यूनिट। ठीक है, क्वांटिटी वर्सेस बेस यूनिट। इसका मतलब ये है कि अब क्वांटिटी भी बेस क्वांटिटी ही होगी। तो यहाँ पे आप कंपैरिजन कर लें। पहला है करंट इज अ बेस क्वांटिटी और उसकी यूनिट एम्पेयर जो है वो आपके पास एम्पेयर इज द बेस यूनिट। Force is not base quantity. Newton is not base unit. So mass is base quantity, but mass का जो unit है gram, that is not base unit. Okay. Temperature is base quantity, but degree centigrade is not the base unit of temperature. So option A is correct. A car of mass is the mass of car is 850. It's traveling horizontal straight line. The diagram shows the two horizontal forces acting the car in the opposite direction. One force has magnitude this, they are already mentioned on the diagram. So what is the magnitude of acceleration of the car? You have to find acceleration. The net force on the car is not zero, as you can see from the diagram. The forward force is 1200, backward force is 1600. So we will use Newton's second law, the special case of Newton's second law, that is F is equal to ma, to find acceleration of the car, where F is the net force, that is 1200 forward force minus backward force. Obviously, the car will be decelerating as the net force is in the backward direction. So 1200 minus 1600 is mass is 850 time acceleration. So you can find which is minus 400 divided by 850. That will give you acceleration, and we are concerned with the magnitude of acceleration. Okay, so right now that negative sign shows over here the deceleration, but we are concerned with the magnitude of acceleration. And if you divide 400 with 850, you will get 0.47 meter per second square. Okay, very simple, straightforward question. So let's move towards the question number 3. An object of mass is suspended by the spring from a fixed point. The spring has a spring constant K. The object is set into the vertical oscillation of the period T. This T is time period, and so the unit of T is second. Which equation for T is homogeneous with respect to the base units? So what do you mean by homogeneous equation? Homogeneous equation is the equation which have same SI base units on both sides. Okay. So we have to pick a relationship for the time period which is homogeneously correct. Okay. So, in all these expressions, you can see K is the string constant and M is the mass, T is time. So what's the unit of spring constant? Hooke's law is F is equal to Kx. If we make K as a subject, that would be F by X. Okay. So F is kg ms minus 2 divided by m. So SI base unit of K in terms of SI base unit is S kg S minus 2. Okay. So let's take option A. On the left hand side, its unit is second. 2 pi has no unit, so let's not worry about this. K is kg S minus 2 divided by kg. You can see on the right hand side, unit is not second, so these units are not equal. So that means that this relationship is not correct. Okay. You can check the second one, ms kg divided by kgs minus 2. So that is s power 2. On the left hand side, you have s. So again, this is not homogeneous. And C is inside the square root, you have kg s minus 2 divided by m kg. So apply this operator square root, you will get s power minus 1. Okay. On the left hand side, you have s, so not correct. Obviously, the last one should be correct, but we can check it. S, so kg square root divided by kgs minus 2. You can see, if we cancel this, we will be left with 1 over s minus 2, that is s positive 2 for s second. This equation is homogeneously correct. So D is your right answer for this question. It's a very important question. An object of fixed mass is initially at rest at point P. The object is then moved away from the point P with uniform acceleration. This is very important deciding keywords. The object has uniform acceleration. Okay. This statement describes the resultant force acting on the object. So we have to tell K what is the resultant force. If acceleration is uniform, that means K, if acceleration is constant, this shows that net force, resultant force on the object should be constant. Okay. So the resultant force constant means it increases uniformly with respect to time. No, it should be constant. It is constant but not zero. Okay. This is the true option. Why it is not zero? Because as you know, zero is also a constant value. But if it is having uniform acceleration, that means net force is not zero and it has constant value. So B is obviously correct. Why? It is proportional to displacement from point P. It's very straightforward. If acceleration is constant, net force should be constant. And D is, it is zero. If acceleration is zero, if the velocity of the object is uniform, then net force must be zero. So over here we have B as correct option. Let's go towards fifth question. A projectile is launched at an angle of 25 degrees to the horizontal with horizontal component of the velocity 30 meters per second. So we are given horizontal component of velocity. You know, if it is launched at an angle of 25 degrees, this is velocity. Okay. But right now we are given horizontal component of velocity, that is 13 meters per second. And what do we have to find? We have to find the vertical component of the velocity. So the vertical component of velocity is this, Vy. And what's the relationship between the horizontal component, this angle? If you know, if we make a right angle triangle, both horizontal component and vertical component are perpendicular to each other. We are given this and we are given this angle 25. So we have to find this Vy. We should think that if it is a right angle triangle, then which trigonometric ratio can we use? So we should use tan of 25 is equal to Vy divided by 13, perpendicular over base. So Vy should be equal to 13 tan of 25. So please be careful while using your calculator. Should be in degree mode. Most of the students don't care about this and accidentally calculator. If the calculator mode is in red, then you will get wrong option. Okay, so if you will do this, you will get 6.1, which is B. Okay, so very straightforward question. Let's move towards question number 6. A ball is released from rest at position X at time t equal to 0. At time 1 second, it bounces inelastically from a horizontal surface and rebounds, reaching the top of its first bounce at 1.5. You can see from the diagram, this ball is released from some height that comes down with the constant acceleration. If its acceleration is constant, then its velocity increases uniformly. That is the time at which it is dropped. And it hits this surface with 10 meter per second. Okay. Then it rebounds with speed 5 meter per second. While it leaves the surface in the upward direction, its velocity is 5 meter per second, minus 5. It goes up on the same line. I have drawn it at a different line. It goes in the same line. And at 1.5 sec, after further 0.5 second, it is the top of its height after first bounce. So what do we have to find? What is the displacement of the ball from its original position X at time t second? So, you know, displacement is a vector quantity, and that is the shortest distance from the initial position to the final position. So this is the displacement D. Okay. So now let's start thinking, how can we find this D? You know, velocity time graph, area of the velocity time graph gives us displacement. So if we find area of this triangle, we will get this whole height. What's the area? This is right angle triangle. So 1 by 2 base 1. This is base time height is 10. So the area of this is 5 meter. That shows the initial height from which it is dropped. In the area of this triangle, if you calculate area of this triangle, that will show you the height it reaches after first bounce. And let's calculate it. Area 1 by 2 base is this time, that is 1.5 minus 1, which is 0.5 time this 5. Okay. So that is, if you will calculate this 0.5 into 5 uh, divided by 2, you will get this height. Okay. And subtracting this height from this 5 meter, you will get this displacement. So just subtract this 5 minus, can I get a calculator? So 0.5 times 5 divided by 2, this is 1.25. So 5 minus 1.25 will be your displacement. So that is 5 minus 1.25, which is 3.75. B is correct option. So very straightforward question. What is the definition of acceleration? Acceleration is, you know, delta V change in velocity with respect to time. So change in velocity per unit time, delta V over delta T. This is correct option. Rate of change of speed, no. Rate of change of velocity per unit time, no. If it were would be rate of change of velocity, this is correct. But per unit time, that means delta v over delta t. This is rate of change of velocity. Then if you divide this with time t, that would not be an acceleration. Resultant force per unit mass, that this equation doesn't define acceleration. Although this equation is correct, acceleration is F by m. But that is not the defining equation of acceleration. Two balls P and Q of equal masses. Okay, they have equal mass, identical balls, move along a straight line directly towards each other, as shown. Their velocities are given. Their speeds are mentioned over there. So, because velocity has direction, so as they're moving in opposite direction. But on the diagram, they are shown both with positive numbers, so their speeds different. P and Q collide with each other. The collision is perfectly elastic. This is a very important word. Okay, that can decide the answer of our question. So you are advised to underline these type of words in exam. The total momentum is conserved. This diagram correctly shows the motion of P and Q after the collision. You know that if there is perfectly elastic collision, then total kinetic energy is conserved. Then speed of approach, relative speed of approach is equal to relative speed of separation. Or if two balls are exactly identical, then their velocities are interchanged. That is another special case. If they are completely identical, their velocities are interchanged. So if P is moving towards right with this velocity, then Q will move with this velocity after the collision. Okay. So, and if P is moving towards right direction with this velocity, and P will get this velocity after the collision. So P will move towards the left with velocity of 0.5, and Q will move towards the right with velocity of 1.3. So you can see from the options, D is correct. Okay. Or in other words, their speed of approach, that is, if they are moving towards each other, the speed of approach is the sum of their speeds, that is 1.8 meter per second. And if they are moving away from each other, their speed of separation will be the sum of these two speeds, that is 1.8. Okay. This is how you handle this question. But if these balls are not identical, then the speed of approach must be equal to speed of separation. Then their velocities will not be interchanged. But you have to use the concept of speed of approach is equal to the speed of separation. Okay, so let's move towards question number 9. So very easy question. A basketball player hits the ball vertically downwards with speed of 2.4 meters per second from a height of 0.9 meters. What is the speed of the ball as it hits the ground? We have to find speed at this point. Let's call it v. So we are given initial velocity. We have to find final velocity, and we are given height. So which equation would you use? Equation of motion. Which equation of motion would you use? You know, initial velocity, you have to find final velocity. You are given height. So we can use this equation. 2as is equal to v square minus u square. Okay, so 2 times acceleration is 9.81. Let's take downward direction as positive. So acceleration is downward. This velocity is downward. So height is 0.9 meter. V square minus u square, that is 2.4 square. If you will simplify this, if you will find V, you will get this answer, 4.8 meter per second. This is again very simple question, so no need to worry about it. A ball falls through a liquid at constant speed. It is acted upon three forces: upthrust, drag force, and weight. If the ball is falling at constant speed, let's look at the forces. Weight is acting in the downward direction, upthrust in the uh, upward direction, and viscous drag force acts in opposite direction of motion. So as it is moving down, so drag force must act in the upward direction. And the second thing is, this is moving at constant speed. This is again a very important word. If it is moving at constant speed, then the upward forces must be equal to downward forces, meaning F drag plus F upthrust must be equal to weight of this object. Okay. So we know this. And if it is moving inside the liquid, then upthrust shouldn't change. Upthrust shouldn't change. So the drag force increases with increasing depth. Drag force depends on the speed of the object. If speed of the object is not changing, as it is mentioned in the question, then the drag force must not change. The drag force is equal to the sum of upthrust and weight. We know that drag force is not equal to the sum of weight and upthrust, but it is equal to weight minus upthrust. So this is again incorrect. The upthrust is constant with increasing depth. Okay. As this object is moving inside the liquid, and the liquid displaces, the volume of the liquid displaces not changing. So upthrust in the liquid is remains same. You already know this. For example, this is liquid. Upthrust at this point will be same as upthrust at that point, because upthrust depends on the volume of the liquid displaced or the volume of the object if the object is completely inside the liquid. But if it is moving, if it is in this position, then upthrust will be different than this upthrust at this position. But as it is moving, falling through the liquid, that means upthrust is not changing. The weight is greater than the sum of drag force and upthrust. Weight is not, weight is equal to the sum of drag force and upthrust. Okay, very simple. Some small solid cubes each have mass 1 kg and sides of 5 centimeters. These small cubes are stacked together to form a large solid cube with sides of this 2 meters. What is the weight of the large cube? Okay. So uh, the volume of all of the small solid cubes should be equal to the volume of one large cube. Okay. So if we know that volume of the one small cube is 5 length into breadth into height, that is 5 cubes, 125 centimeter cube. But the large cube is given in meters, so we should convert this centimeter into meter or meter into centimeter. It's your choice. So if we convert this centimeter into meter, that is 10 power minus 2 meter cube, which is 125 times 10 power minus 6 meter cube. This is the volume of small cube. The volume of large cube is 2 into 2, 2 cube, that is 8 meter cube. If we divide the volume of large cube with the volume of small cube, we will get number of cubes. The number of cubes will be 1 to 5 times 10 power minus 6. These are the number of cubes. Number of small cubes. And we know that Each small cube has a mass of 1 kg. If we know number of small cubes, then we will multiply with 1 to get total mass in kg. And for weight, we will multiply this mass multiply by g, gravitational acceleration. So if you do this, 8 divided by do it if you have calculator. मुझे दूसरा कैलकुलेटर नहीं मिला, इसकी कुछ नहीं मिली यार। हम्म? तो करो। So try to do it. It's very simple. I have told you the recipe. Number of small cube multiply by 1. So the mass of all the small cubes, okay, multiply by G will give you the mass of a large cube. So the answer will be C. If you will convert this, right now my calculator is not properly working, so I leave this question to you. Okay, so let's move towards question 12. A borehole of depth 2000 meters contains both oil and water, as you can see on the diagram. The pressure due to the high liquids at the bottom of the bore is this. We are given total pressure at this point. The density of the oil is this, and the density of water is also known. What's the depth of oil? X of the oil. We have to find this X. So what is the basic idea? The total pressure at this point due to these two liquids, as the container is closed, so there is no effect of atmospheric pressure. So total pressure at this point will be the pressure due to water plus pressure due to oil. Okay. So pressure due to water will be P total is rho of water G H of water. What is the height of the water column? That is 2000 minus X plus rho of oil G times X. So you will put total pressure, that is 17.5 mega mean 10 power 6 Pascal. Rho of water is 1000 times 9.81 times 2000 minus X plus rho of oil is 830 times 9.81 times X. So I hope you can solve this equation. This is a linear equation. You have to find X. And I am 100% sure at this stage you can find this. So if you will make X as a subject of the formula, you will get 1270. Okay. The rod is pivoted at 1, and initially the angle theta of the rod to the horizontal is this. This is rod, and that is pivoted at this point. So initially the theta is 0. The weight of the rod causes the moment W, this is weight, this is uniform rod. So initially the moment must be, let's say this distance is d. Initially the moment is W into d, that is maximum. When this rod rotates, let's say I draw a position of this rod after some angle, the weight is this, and this is b. Now the distance from the pivot, shortest distance will be this. This angle is theta. And now this distance is b cos theta. And the moment at this stage will be W b cos theta. You can see the moment initially is maximum when cos theta is 0. cos 0 is 1. Moment should be maximum, and as theta increases, moment should decrease. Okay, so that option is not possible. And this is also not possible because we have cos theta there. And when theta is 90-degree, moment will become 0. In the rod will be at this position. In this position, the moment will be 0. But after this position, if you draw the position of this rod after 90 degrees, the weight will be like this, and this angle theta will be more than 90 degrees in this case. So if this is theta, that angle will be 180 minus theta. And this right now moment would be W. This is the cos of 180 minus theta. And cos of 180 minus theta is minus cos of theta. So W d cos of theta, it is negative now. So that's why this option, the direction of moment changes. Till 90 degree, the moment is in the clockwise direction. After 90 degree, the direction of moment is anti-clockwise direction. So that's why this option A is not possible. Even if you don't do this type of calculation, you know that the direction of moment changes after 90 degree. Okay. So then it will be having in this direction moment. So that's why the option D is correct. This is a very important question. This is again a very interesting question, and hence trap door is held closed in the horizontal position by the cable. Three forces act on the trap door: weight W of the door, tension T in the cable, you can see in the diagram, and H is the force that hinge applies on this trap door. There are three forces that are drawn over there, and this hinge is in equilibrium. So what we have to find, which list gives the three forces in increasing order of magnitude. So we have to sort out these forces, which force is the least and which force is maximum. So how to do this? There are different possibilities. So let's resolve this. Let's say this is theta. Resolve this T, which is P of y vertical, a PV, and this component is Px, yeah, P horizontal. And resolve this H. This is H of V vertical and H of horizontal. If this rod is in equilibrium, the first condition states that the net force must be 0 in any direction. That means horizontal forces must cancel out, vertical forces must cancel out. So vertical forces, upward force is PV, downward force is HV plus weight. That shows that the vertical component of this tension is equal to the sum of weight and the horizontal component of this vertical component of this tension. From this, we can say the vertical component of tension is greater than weight. If vertical component of tension is greater than weight, then tension must obviously be greater than weight. Okay. And the vertical component of tension is also greater than vertical component of V, H, vertical component of H. And you can easily see vertical component of tension is T sine of theta, and if say this is alpha, this must be H sine of alpha. So as you know, theta is greater than alpha. So sine theta is greater than sine of alpha. Okay. So tension is greater than weight, and tension is also greater than the H. So that means the tension is greatest. And if you look at the options in which tension is the greatest, we have only one option where tension is the greatest. So tension is greater than this weight and H. Okay. So if we had another option where we had H, W, and tension, then this question would become more technical. But right now we have only one option, so can start it. What is the definition of force? So very simple definition. Newton's second law, F is equal to rate of change of moment. So delta P over delta T. Don't try to use this F is equal to mf. This is the special case of this equation. So general equation for the Newton's second law and the definition of net force is this is the rate of change of momentum. So rate of change of momentum is the net force. The boat moves at constant velocity through the still water. Okay, so if the boat is moving with constant velocity, a constant drag force F acts on the boat. If it is moving with constant velocity, so driving force must be equal to this force. So we have to find the power use. Power is driving force times velocity, that is F into V. Very simple question. Question number 17. Diagram shows four forces acting on the circular disc. You can see these four forces, 1, 2, 3, 4. Each force has magnitude F. Two of the forces act vertically, two horizontally. All forces act on the same plane as the disc. No other forces act on the disc. So let's do what is the net force. These two forces cancel, so there is no horizontal force, there is no vertical force. So F net is 0. Okay. So net force on the disk is 0. But what is net moment? This force rotated in this way, that force also rotated. So net moment is not 0. If you find the net moment of all these forces, so disk has diameter dv, these two forces form a couple. So moment of couple is one of the force multiplied by d. So moment due to these two forces is F3, and moment due to these two forces, they also form couple F into D. So the total moment is 2Fd. So net force is 0, and the net moment or net torque is not 0. The moment of couple is known as torque. Okay, so very simple, straightforward question. So the disk is not in equilibrium as the net moment is not 0 because the resultant torque is 2Fd. Okay, resultant force is 0, that is not 4F. So resultant torque is not 0, but resultant force is 0. First condition of equilibrium is satisfied, but the second condition is not satisfied. So that's why this object is not in equilibrium. This is again a very good question. A ball is projected into air from the horizontal ground and follows the path shown. That is the path followed by this object fall. So we have different points Q, R, S, P, and their heights are given. And the kinetic energy at these points are mentioned as by these symbols. Air resistance is negligible. Which difference is the kinetic energy the smallest? You already know that the speed of the projectile is maximum at this point, and speed is minimum at the top, and the speed is same at the same height. Okay. So at the same height, the points having the same height will have same kinetic energy. Okay. So let's say we have point somewhere here with height. Let's say this is right. And we will have a same point with the same height over here, and the kinetic energy at these 2 points will be same. So the difference of kinetic energy depends on the difference of heights of these 2 points. That's again very important. So difference of kinetic energy at point Q and R depends on this difference of this height. Okay. As the difference of this, the heights of these 2 points is 0.3. So the kinetic energy will depend on this difference. Okay, so we have to find or locate those 2 points which have the least difference in height out of these 4 points. So Q is 1.5, S is 1.6. So difference between the height of these 2 points is 0.1. And you can see any other 2 points will have difference more than this. Difference of this point, Q versus T is 0.2. This versus this is 0.3. That versus this is 0.2. This versus this is 0.5. Okay. So this is a very important point. So the kinetic energy, the difference of the kinetic energy at point Q and S will be least. Okay. So EQ versus ES. This is the least. This difference is least. So if we had to find the maximum difference in the kinetic energy, then we would have seen the 2 points with the greater difference in their height. Okay, a battery of small tablet computer is initially uncharged. It is connected to a constant 10-watt power supply for 2 hours. So we are given power versus time to charge this battery. The efficiency of the charging process is 80%. What is the total energy stored in the battery? That is the output energy. Okay. So what is input energy? Input energy is power into time. You know, power is energy by time. So energy is power into time. So E input is power is 10 watts, time 2 hours, hours being in seconds. That will be 3600 seconds. This is input energy. And you know efficiency is 80% and efficiency is output energy over input energy multiplied by 100. This is in percentage. So we have to find output energy. That is 80% of 80 E output. We have to find E input is this. So if we divide this 80 by 100, we will get 0.8 time input energy is this multiply is equal to output. So we have to find output energy, that is 80% of the input energy. Okay. So 80% 0.8 time of this energy will give you, if you will use your calculator, you can find this easily. The answer would be 5.8 times 10 power 4 joules. And initially stationary firework explodes and splits into 2 fragments that move horizontally in opposite directions. The total kinetic energy transferred to the fragments by the explosion is E. One of the fragment has mass m and other has mass 2m. Okay, so initially a large fragment explodes and this generates 2 fragments that move in opposite direction. One has mass 2m and other has mass m. Let's say it moves with velocity v1 and that will move with velocity v2 in opposite direction. Okay, these are speeds. So we are given the total kinetic energy of these 2 pieces. Okay. What is the speed of the fragment of the mass m immediately after the explosion? We have to find this v1. So how do we do this? So first we should apply the conservation of momentum to find the relationship between v1 and v2. The total momentum before is 0 because this fragment is at rest. And the total momentum after is 2m time v1, v2, and that is in opposite direction, plus m time minus v1. So 2m v2 is equal to mv1. That gives us the relationship between v1 and v2. Now we will use the second condition that total kinetic energy is E. That shows if their total kinetic energy is E, so E is the total kinetic energy, and that is half mv1 square plus half 2m v2 square. Okay. So just put v2 is, we have to find the velocity of the smaller piece, that is v1. So eliminate this v2. v2 is equal to v1 divided by 2. Just put over here. You will get a relationship between v1 plus, let's cancel this, m v2 is v1 by 2 whole square. Now you can make this v1 as subject of a formula easily. It is not a big deal for you. I hope so. So if you will make this v1 as subject of a formula from this equation, you will get this option B. A spring is fixed at one end and extended by applying force F to the other end. The spring has extension and elastic potential EP. The spring constant is K. So spring was at first, we applied force F. That causes extension in the spring. And you know that if it is obeying Hooke's law, the relationship between F and X is F equal to K. So we have to find elastic potential energy. Elastic potential energy, if it is following Hooke's law, this is F, that is X, is equal to area under this graph. So 1 by 2 F into X, EP. And EP is not proportional to F as X is also changing. So option A is incorrect. EP is not proportional to X as F is also changing. EP spring constant is constant. So F is equal to Kx. If I use this, I will get Kx square. So you can say, see, this K is constant and EP is proportional to X square. So option D is correct. A force extension graph is produced for a metal wire. What must describe the limit of proportionality of wire? Very straightforward question. Limit of proportionality is the point behind which the Hooke's law is not obeyed. Very simple, straightforward question. D. 23, we are given two springs with their spring constants mentioned on the diagram, and we have to find the total extension of this composite spring. Using these two springs, we have formed a composite spring, and we have to find the total extension. There are two possibilities to do this question. Either find the total spring constants, as these two springs are connected in series. And in series, you know, 1 over K total is 1 by K1 plus 1 by K2. If there are two springs constants, then K total can easily be obtained using product over sum. And their product is 6 into 4, and their sum is 6 plus 4. So 24 over 10, that is 2.4. This is K total, Newton centimeter per centimeter. So F is equal to K total multiply by extension X. So F is 80 Newton, K total is 2.4, X is this. So if you divide this 80 by 2.4, you will get the total extension, that is B. 33. 80 divided by 2.4 will be 33 centimeters. Another way of doing this force F is same on both springs. So find extension of each thing. मानिए तो देखो यार. So extension in each thing would be 80 is equal to k is 4 time x. Extension in this thing will be 20 centimeter. And extension in this thing is force is same, tension is same. 80 is equal to 6 times x. 80 by 6, that gives you 13, around 13. So the total extension will be 33. A range of frequencies of sound waves emitted by the blue whales is this. These are the range of frequencies. The speed of sound is approximately this. We have to find approximate range of wavelengths. Okay. So wave equation is V is equal to F lambda. First find the lowest. If you use 10 hertz wavelength, 10 hertz frequency, then the wavelength is V over F. That will give you 1.5 times. It's in kilometer per second. So you have to convert this into meter divided by the frequency 10. That will give you, if you are using the least frequency, you are getting the maximum value. Okay. So 1.5 times 100, that will cancel. So it's 150. 150. This is maximum wavelength. And what about the minimum wavelength? You will use the maximum frequency, which is 1.5 times 1000 divided by 40. So you will get 25 on this is 38. So so the right answer for this option is D, 24, D. 25. We are given a wave is detected, microphone is displayed on the screen, cathode ray oscilloscope. You can see the frequency of the wave is this. So what is the setting on the time-based setting? To find the setting on the time-based setting, we should find time period. The cycle is completed in 4 centimeter, and the time period is 1 over frequency, that is 1 over 2.5 times 10 power 3. Okay, this will give you 1 divided by 10 power 3. That is 4 times 10 power minus 4 seconds. So we should convert this into millisecond, as you can see in all options. Millisecond, millisecond, second, second. So these 4 boxes represent 4 times 10 power minus 4 seconds. Okay. So this one box must represent, we divide this 1 into 10 power minus 4 second per centimeter. This is second per, it's not 0.1 second per centimeter, 0.4 second per centimeter. So if we convert this into millisecond, that is 0.1 times 10 power minus 3 second per centimeter. That is 0.1 millisecond per centimeter. A source of sound waves with a constant frequency moves towards the stationary observer. The observer compares, so observer is at rest and source moves towards observer. Compare the sound waves around the observer position, waves emitted by the sound of the sound. What are detected by the observer? Know that frequency observed by this observer will be greater than the source frequency, or wavelength will be smaller than the original wavelength. And decreased frequency of sound waves, no, it must increase. No change in the frequency, no. A decreased wavelength, okay. No change in the wavelength. So C is correct. Which type of wave can't be polarized? We can only polarize uh, transverse wave. Longitudinal waves can't be polarized. Okay. So sound waves are longitudinal waves, but they can't be polarized. Other three waves are transverse waves. Radio waves, ultraviolet waves, X-ray waves. These all are electromagnetic waves, and they are transverse waves where the electric field and magnetic field oscillate perpendicular to the direction of wave transfer. Question number 28. A beam of light with power P has an area of cross-section A. Okay. The amplitude of this power P, the amplitude of the light waves in the beam is X. Okay. So a beam of light is then changed to 1 with the same frequency, but the increased amplitude. When amplitude has increased, cross-sectional area has decreased. What's the new power? You know, intensity of wave is power per unit area. And how to link amplitude with intensity? You know, intensity is square of amplitude. So I can say this intensity is proportional to amplitude square. So I can say K x square because amplitude is x is P over A. So P is A K x square. This is obtained by this information. Let's say this is equation first. In the second case that starts from here, amplitude has increased to 4x. So I use this equation and intensity is K times 4x whole square. It's proportional to amplitude square. And power is, we have to find that power, P of nu divided by area is A by 3. So let's take this on the other side. This 3 will go on the, so 3 power nu is equal to K 16x square times A. Okay, so we have these two equations. If we divide this equation with this equation, P A K square, this A will cancel, this K will cancel, that x square is this. So power nu is 16P divided by 3. 16P divided by 3 is, I think so, it's 5.3P. It's 5.3P. It's a very simple question, but you have to concentrate. So area is, amplitude has increased by a factor of 4. And apart from that, area is also decreased. So we have to consider these two factors. So that's why we have to make equation. Two loudspeakers are connected to the same signal generator. The signal generator produces a single frequency. Loudspeaker face each other so that stationary sound waves is set up in the region between the loudspeakers. A microphone is connected to the cathode oscilloscope and positioned between the two loudspeakers, you can see. The microphone is moved along the line joining the two speakers. So microphone is moved along this line. The signal on the CRO shows 5 maximum amplitude as the microphone moves. Maximum amplitude means antinode. Five antinodes. The microphone's at distance at 2 meters. So that distance whole is 2 meters. We have to find wavelength. So very simple question, you know that distance between two adjacent nodes is lambda by 2 and distance between these two nodes is lambda. This is lambda by 2, that is lambda. So that means this is equal to 2 lambda. So bachcho 2 lambda is equal to 2 meters. So lambda must be equal to 1 meter. Okay, lambda is 1 meter. It's easier. Two wave source emit a coherent wave. What do you mean by coherent wave? Very straightforward question. The waves have constant phase difference. The phase difference between the waves must not change. If these two waves have 180 phase difference, for example, that should remain 180 for all time. If these two waves are in phase, for example, they must remain in phase for all times. Their phase difference shouldn't change. A student set up an experiment to investigate the double slit interference. The student uses light of single wavelength, you can see, from the laser to illuminate the double slit so that the pattern of interference fringes is observed on the screen. Okay. So the student finds the fringes are very close together. X is very small. You know, fringe spacing is wavelength, this distance, Q, and this distance R. So if his X is very close, what does student want? What could be the student decrease in order to increase? He wants to increase X. Okay. So if we want to increase X, he can increase this Q or he can decrease this R. So consider this word decrease. So we have to find that thing which must be decreased in order to increase X. So R is the answer. Okay. So R is the separation of the sets R. Okay. Let's move forward. What's the definition of potential difference and an EMF in terms of they have the same definition, work done per unit charge, but in one case, the work done is energy is transferred from chemical to electrical. In another, the energy is transferred from electrical to other form. So work done per unit charge, very simple. 33 diagram shows the network consisting of three resistors. You can see them. These two resistors are connected in parallel, and their result is connected in series. What is the combined resistance? Very simple. Very simple. So the resistance of these two will be, let me call this as R, R, P of these two resistors is, if two resistors are in parallel, then their equivalent resistance is product over sum. That is 1.2 over 1.2 into 4.7 over 1.2 plus 4.7. This answer added to this answer will give you the final answer. Okay. The answer of these two resistors will be less than 1.2. If it is less than 1.2, less than 1.2 added to 2.2, 2.2 plus 1.2, this is 3.4. So answer must be less than 3.4. Okay. So that will not solve your issue. There are many answers that are less than, but it must be greater than 2.2. It must be greater than 2.2. So 2.2 and less than 3.4. So we have only one option. There is no need to do calculation for this question at all. If two resistors are connected in parallel, for example, this is 1 ohm, that is 2000 ohm, the answer will be less than the least resistance in the combination. Okay. A resistor dissipates power 25 watt, potential difference is 4. So power is V square divided by R. We have to use this resistor because we are given this definition of the power. We have three, VI, I square R, and V square R. So use this. Power is given. We have to find resistance very straight away. So V square over power, that is 4 square divided by 25. That will give you your answer. Okay, बच्चों, that is 34B, 0.64. Diagram shows a cell with the internal resistance that you can see in the diagram and a fixed resistor and a variable resistor. The resistance of variable resistor is decreased. This is very important. This is decreased. What happens to the potential difference V? This potential difference and the current through the resistor. So, bachcho, you can easily see that if you will decrease this resistance, the resistance of overall circuit will decrease. Okay, this resistance plus the parallel combination of these two resistance will be equal to the total resistance. If you decrease this resistance, variable resistance, then the total resistance will decrease. And the resistance of this combination will decrease. If you use potential divider concept, the potential difference across these two components will decrease. V will decrease. Okay, V decreases. And what about I? If V decreases, obviously I must also decrease because the resistance is Ohm law is V is equal to IR. Okay. So 35, no. Let me again think. The resistance of variable resistor is decreased. Okay. So you know that in case of potential divider, if you increase, if this is V output, and if you decrease this resistance, V output will decrease. So voltage will decrease. What about current? If voltage decreases, this resistance is decreased, overall resistance of the circuit will decrease and overall current will increase. Okay, so that's why B is correct. Overall current will increase. That's very important thing. Because by decreasing this resistor, the overall current will be increased. If overall current increases, the portion of this current will also increase. Okay, is that clear? 36. A radioactive source produces a beam of alpha particle in vacuum. The average current caused by the alpha particle is I is 1.5 times 10 power minus 19. Oh, I'm sorry, it's 9 ampere. The beam is incident on a metal target. What is the average number of alpha particles hitting the metal target in this file? Okay. What is the charge on alpha particle? Charge on alpha particle is positive 2e. That is 2 into 1.6 times 10 power minus 19. This is charge on alpha particle. And if we know current, and if we know time for 3 seconds, we can find the total charge. Okay, the total charge is I is Q by T, so Q is I into T, that is 1.5 times 10 power minus 9 times 3 seconds. This is total charge, and the charge of alpha particle is this. If we divide this total charge by a charge of alpha particle, we will get the total number of alpha particles. Okay, so 1.5 times 3 times 10 power minus 9 over 2 into 1.6 times 10 power minus 19. That will give you number of alpha particles. Number of alpha particles. That is C. Simple. A charge carriers in metal wire are free electrons. Which statement about the charge of the each of the electron is correct? The magnitude of the charge increases with the potential difference. No. Charge on charge carriers electrons, it has no effect. Potential difference has no effect on the charge. The magnitude of charge is 0 unless the potential difference is no. The charge is always there. They don't have any, they have random motion. So when you apply potential difference, they start moving in one direction. The sign and magnitude of the charge don't depend on the potential difference. Okay, that's good. Which levels of quark have 2 by 3? Very straightforward question. So what is the, for your ease, I have shown the charge of each charge. Quark, up quark has charge 2 by 3e. There is no option of up, charm, strange, top, bottom. And charm has also charge 2 by 3e. So charm should be text. And what is the charge on the top? It's also has 2 by 3e. So, we have only one option, this top 2 by 3, charm 2 by 3. You can see strange has charge of minus 1 by 3 and bottom has charge of minus 1 by 3. So option A is correct. An unstable nucleus of element decays by emitting alpha particle and beta particle to become a nucleus of a different element. The nucleus is also unstable and emits of alpha and beta particle. This process continues until an isotope of original element is produced. If X is AB, what is the definition of isotope? Same charge number, but different nucleon number. So finally, Y is formed with this number 10. What's the minimum possible number of these particles? Okay, so by emitting an alpha particle, let's say an alpha is emitted, alpha is charged 2 and this number 4. This number is decreased by 2. So if only alpha is emitted, then their charge number of X and Y can't be same. So by emitting a beta particle, for example, X 10, 20, and you emit a beta particle minus 1, 0, that becomes 11, and that is 20. So emission of beta particles increases this number, and emission of alpha particle decreases this number. So if an alpha is emitted, then this number is decreased by 2. Then there must be at least 2 beta particles. So this is minus 2, that is 2, so that this number is unchanged. So the minimum number of these particles must be 3. Must be 3. They can't be 2. If you emit 1 alpha, 1 beta, if only alpha is emitted, this number must change. If only beta is emitted, this number must change. But if alpha and beta both emitted, then if 1 alpha, 2 beta, then this number must not be changed. If 2 alpha, 2 alpha and 4 beta, then again this number must not be changed. So we have to find the minimum number, which is 3. So last question, a nucleus of carbon is decays by a beta emission to form a nucleus of it. Okay. So C6, 10, B5, 10, this by beta emission. So which beta? This is B, Bacho, that is B. Beta positive should be emitted so that this charge number is conserved. So for this decay process, what is the change to nucleon and what is the change in the quark composition of the nucleon? Okay, change to nucleon. So nucleon number of C, proton to neutron, okay, we see there are 6 proton and 4 neutron. Okay, there are 5 proton and 5 neutron. That means a proton number has decreased neutron number has increased. So proton to neutron. Proton has converted to neutron. Proton has converted to neutron. These two are possible. So what's the quark composition? If proton has converted to neutron, proton has up, up, down. Neutron has up, down, down. So up has changed to down. Up has changed to down. Up becomes down. Okay, bachcho. So that's why B is correct. So this was the paper that I did in front of you. I hope you learned a lot from this paper. And looking at this paper, you can guess the psyche of the examiner and try to make your own situation, generalized situation, so that you can have a better idea of the paper that you will give. Thank you. I hope if this session was helpful for you, you should share it with your friends, and you should subscribe to my channel. That will be helpful for me.